Greeting everyone, we are from Group G. We'll present to you about the quality of tablet production of the Lajak Kuruih tablet.
Assalamualaikum warahmatullahi wabarakatuh. My name is Muhammad Farhan Azwan bin Muhammad Farid, and as for today, I will be presenting about the question A for this project. As you can see, this is the tabular form for tablet Lajak Kuruih that is sorted based on its parameters, which are weight, relative density, tensile strength, and also production shift. All of these parameters are sorted based on its data range and frequency. All of this data is gained and extracted from the Microsoft Excel, and I illustrate this tabular form based on its data range and also frequency. For a better illustration, I will be presenting about the numerical form and also the graphical data form. As for the numerical data form represents the data in form of numbers, but it is not in any descriptive form. A set of data comprises of mean, standard deviation, and mode for each category represented in the numerical data form. As you can see in table 2, I extracted the data for mean, standard deviation, and mode based on its weight, relative density, tensile strength, and also production shift for the overall data. As you can see, for the table 3, I extracted the data based on its category of production shift, which are morning, evening, and also night. All of these data are sorted based on its category, mean, standard deviation, and also the mode. For a better illustration, I will be presenting about the graphical form later on. As for graphical form, this graphical form represents the data in various types of charts such as bar charts, scatter diagrams, and also pie charts. As for graph 1, these bar charts represent the bar charts of frequency against weight, where the weight is the independent variable while the frequency is the dependent variable. As you can see, the highest frequency for this data is ranging between 350 mg until 360 mg, which gives the frequency of 55. And for the graph 2, which represent the bar charts of frequency against relative density, the relative density is the independent variable and the frequency is the dependent variable, which have the highest frequency of 67, ranging from 86% to 88%. As for graph 3, represent the bar chart of frequency against tensile strength, where the tensile strength represents the independent variable and the frequency represents the dependent variable, which it holds the highest frequency of 71, ranging from 7.1 megapascal until 7.3 megapascal. As for the graph 4, which is the scattered data of tensile strength against relative density, it represents the scatter diagram and it can be simplified in a linear form, which the equation are shown below. As for the last one, for the graphical form, which is graph 5, illustrate the pie chart distribution of production shift. As you can see, the largest percentage of production shift holds by the morning production shift, which is 34%, and following by the night and evening shares the same percentage of production shift, which is 33%. Next, we will be presenting about the question B.
In question B, we are required to comment on whether there is significant evidence that Lajak Laku tablet produced in December 2021 will follow normal distribution. First of all, we need to make a frequency table that will divide the weight according to their categories. The table and the chart of the weight frequency distribution we can see from this table. From the chart, we observe that the highest frequency is 55 with the range of weight from 350 to 360, and the lowest frequency is 3 with the range of weight above 380. Moreover, we have been given the mean and standard deviation, which is 350 and 14 respectively. From the data obtained, we will make the state of hypothesis, which is H0 is the distribution of weight of Lajak Laku tablets produced in December 2021 do follow normal distribution. Meanwhile, H1 is the distribution of weight of Lajak Laku tablets produced in December 2021 do not follow normal distribution. After that, we will calculate the probability of normal distribution for each category of weight to be used in the test statistic table. Then we will create the test statistic to find the chi-square test to compare with the chi-square at 10% level significance. Moreover, from the test statistic, we observe that the expected value at first iteration and at iteration is below 5. Hence, we will combine the expected value and observed value at first iteration with the second iteration. Meanwhile, the at iteration will combine with the 7th iteration. Then, the new test statistic table will form as shown in this slide. From the test statistic, we obtain the value of chi-square test of 2.1502. Lastly, we test the claim at 10% level of significance and get the chi-square with the value of 9.2364. Since chi-square test with value of 2.1502 is lower than chi-square of 9.2364 at 10% level significance, we are unable to reject H0. In other words, we accept H0. Hence, there is significant evidence that Lajak Laku tablet produced in December 2021 to follow normal distribution at 10% level of significance. Hence, we conclude that the distribution of weight of Lajak Laku tablet produced in December 2021 to follow normal distribution at 10% level of significance.
For the question C, we need to comment on whether there is any significant difference between tablets' weight from the different shifts. We need to comment on whether there is any significant difference between tablet weight from different shifts. We can use analysis of variance, that is in ANOVA test, as there are 3 groups of the shift, which is morning, evening, and night. From the data given, we need to sort the shift group with the classification of evening, morning, and night according to the alphabet to ease the job in making a ANOVA table. The hypothesis statement H0 is the mean for group 1, that is morning, is equals to group mu2 and equal to mu3. The H1 is mu1 is not equals to mu2 and it's not equals to mu. This ANOVA table, which we got from calculating in Microsoft Excel, with confidence interval of 95% and also 90%. The confidence interval for 95% have alpha equals to 0.05 and the alpha for 90% interval is 0.1. These 3 groups stands from morning, evening, and night shift. For the rejection rule, the confidence interval for both 95% and 90%, which in the tables stated on the slide, the SS stands for sum of square, DF degree of freedom, MS mean of square, and F calculated. For both alpha, the value of F calculated is lower than F crit. So the conclusion is, we fail to reject H0, then we accept H0. There is no significant difference between tablet weight from the different.
The last part is question D, which is we need to find the relationship between relative density and tensile strength. Due to linear regression, we may use linear equation y equal to mx plus c, and by using Microsoft Excel, we can easily perform analysis, and the interception of y axis is 0.018275 and the relative density is 0.082895, and y is tensile strength and x is relative density. From graph 4, which is line fit of relative density, we can see that the predicted tensile strength is in a linear graph, so we may use the linear equation that we had obtained before. For calculation part, for the first one is 68% relative density. We can substitute 68 into linear equation, and the tensile strength is 5.519135 megapascal. Second one is 74.3% relative density, and the tensile strength is 6.02877735 megapascal, and the last one is 80.1% relative density, and the tensile strength is 6.497964.5 megapascal. From the summary that we obtained from the regression statistic in Excel, we can refer to multiple R, or known as correlation coefficient, and the value is 0.838285, and from that value we can say that there is a significant positive linear relationship between tensile strength and the relative density. That's all. Thank you.